less useful as it's used, and this is because of entropy, the natural dispersion of energy.
Okay. That's not the third law, but that's okay. Don't worry about it. The third law is confusing, kind of, because this is the main idea. So I'm just going to say, we're just going to say that. Energy gets less useful as it's used. This is because of entropy, the natural dispersion of entropy. Energy. Now, I do want to define the third law for y'all also. Entropy. So, as energy gets used, it's less useful. I really like that phrase. I really like that phrase on it's less useful as it's used. And this is called entropy. Huh? Yes. Uh-huh. It is less useful as you use it more. That is true. All right. Let's also go ahead and define the third law. Did you do it down here? Yeah, let's go ahead and do it here. The third law states that you can never reach absolute zero. Can never reach absolute zero. Okay? So the third law basically states how the process... So the zeroth law explains what we're doing as far as measuring temperatures. We're measuring temperature by relating the relationship between their energies. Okay? The first law states that energy is transferred and it has to go somewhere. The second law explains where it goes. It goes from high temp to low temp. And the third law explains that this process is going to be ongoing. Okay? You're never going to be able to completely end it. You're always going to have some energy, residual energy somewhere, which is kind of why entropy goes with this. Because entropy is saying you're always going to have some leftover energy. Okay. All right. Does energy ever go from disorder to order? Okay? Someone answer it for me. Yeah.
Yes, like an air compressor, but not naturally without work.
Okay, so can you go from disorder to order? I like to think from, so this is kind of the opposite way. Can you go from kind of cold to hot? It's not quite the same as order and disorder, but that's kind of the way to think about it. Yes, you can, but it doesn't occur naturally. You have to do work to make that happen. Okay, good. Okay, what's an example of going from order to disorder? So this is this idea of entropy here.
Air dispersion when you blow.
Okay, so when you blow, the air spreads out, it goes away, it cools off. Okay, it becomes less dense and it cools off as it expands. Just getting into it.
So that one's not right.
Yeah, that one's not right.
Yeah, don't worry about it. Yeah, we'll just... Nothing to see here.
We need a third question.
Yep. All right, here's my third question. So what is this idea of entropy? Here's the way I like to think of it. I like to think of it as useless energy. So the book talks about going from order to disorder. It talks about going from energy you can use to energy you can't use. So high temperature things have lots of energy that you can use. But they go to things that are lower temperature that you can't use unless you do work to get them back again. Your book talks about a house that you just leave alone for 50 years. Over time, it breaks down, it gets cracks, weeds grow into it, that sort of thing. Can you get it back to its original state? Sure, but you have to do work to do that. So things naturally on their own go from high-order, usable, helpful energy to low-ordered, less usable, useless, unusable energy. And the thing where this has to do with the third law is you're never going to get to a point where you've used up all that energy. You can't reach absolute zero. Okay? You can't ever get to the point where you've used all the energy. It's not possible. Okay? It's not possible to do. You can get really, really close, but you're never going to get to the point where you've used up all of an object's energy. Okay? So that's this third law states that you can never reach absolute zero. You can't ever use up all the energy. All right, clarifying. Oh, look, it's what I said. All right, so what's the clarification about entropy?
It's just better thought of as useless energy. So one way you could do is like rubbing your hands together. Your hands get hot, but you can't really do anything with that energy.
Yep. So if you rub your hands together, you can increase the temperature. You do work, so you're transferring energy into your hands. But what do you do with that energy? Like, you can't do anything with it. It's there. Like, it's warm, I guess. That's true. But you're not Mr. Miyagi, so you can't do it. Yeah. So you can't really do anything with that energy. So it's low ordered, or it's entropy. It's this useless energy. Okay? So that's what things naturally tend to do. They naturally tend to become less useful over time. Okay? And this is your air dispersion idea, I'm guessing?
It's super focused, and then as it gets further away from the source of work, it gets more dispersed.
Yeah. So it spreads out, becomes less useful. If you have a bunch of particles really close together, you can do a lot of work with that. You can shoot the air out and cause something to spin. You can blow your friend's hair back by blowing in their face in a really creepy way. But as you stand further back, that becomes less useful, and you can't use that energy as well as you could before. So I could try to blow your hair across the room, but it's not going to be as effective as if I tried to blow Sawyer's hair, which I'm not going to do because that's creepy. Everyone else is like, oh my gosh. Guys are interesting. All right. Let me add one last thing here. So here's a different way to think of the three laws. A, B, and C. Here's a different way to think of the three laws. First, second, third. You can't win. You can't break even. And you can't get out of the game.
Sounds like a cult.
Yeah.
Dude, that game sucked yesterday.
So, you can't win. You can't get more energy out than you put in. It's impossible. That's the first law. First law is the energy has to come from somewhere. So you can't just magically have 7,000 joules come from nowhere. It has to come from 7,000 joules of work. Or it has to come from 7,000 joules of energy transfer. Or 7,000 joules of temperature change. It has to come from somewhere. You can't break even. You can't even get out all of the energy that you put in. some of it is going to cause internal energy change. It's always going to do that. There's always going to be some internal energy change. And you can't get out of the game. You can't ever use all the energy. You can't use all the energy. You're never going to get all the energy used. You're always going to have some left over in internal energy. You can't reach absolute zero. So you can't win conservation of energy. You can't break even. Heat transfers from hot to cold naturally, and never all of it. And you can't get out of the game. You can't reach absolute zero.
What about when I run out of gas? Yeah.
No.
What if I run out of that E85? Yeah.
Is that what your truck runs on?
Oh yeah.
It's a flex fuel, right? You can run all kinds of stuff on it. Okay? Can't win, can't break even, can't keep out of the game. Just a different way to kind of think about those. All right, any questions on any of those 4 things? All right, you can go